Hello guys, welcome back to my channel. In this particular video, we will continue with our second part. I hope you have already watched our first part, whereby we converted the decimal numbers to binary number using the long division method. In case you missed that part, you can watch the other video that I've already posted. Okay, for this one, we are going to use the place value methods to convert numbers or decimal numbers to binary numbers. And before we do that, we need to remind ourselves something small on the decimal. And decimals, these are numbers that uses 10 different digits as the number system. That is from number 0 all the way to number 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, and lastly the 9. While for the binary, the other number, this is a 2-digit system and it uses 2 digits, that is 0 and 1. Okay, if you had watched the other video, you will find that the steps that we had treated down there are quite a few compared to this one, but maybe you will judge based on how you understand the two methods of converting the numbers from decimal to binary. But for this one, you just write down the number to be converted. Then number 2, generate the base 2 place value of the given decimal number. Not that you generate base 2 place value, the first place value should be less than but nearest to, or alternatively equal to the number. Then number 3, you take the generated place value and you subtract it from the given number. Then you write down the base number place value below each of the generated place value. You write 1 below the place value that exists both, not this other one. You write 1 below the place value that exists this particular part. It's very important, this one. You write 1 below the place value that exists in both the generated value and the normal base 2. Then for the other one, you just write 0. The other one, okay, let me include that part. Then write 0 below the place value that only exists in the normal base 2 place value, but in generated not the generated parts. So those are the key parts, especially this one. Whenever you have this one up to this one, you need to note that these are very key part. You are supposed to write 1 below the place value that exists both in the generated and the normal base place value. While if the number appears only in the normal base 2 place value, you just write the 0. Okay, let's move to the example. Example will give us a rough idea on how to go about the whole thing. So the first number we have is 16, base 10. So you need to think of a number that is near or equal to or is less, slightly less. So if you look over a number, we have any number. This one is supposed to be 16. The number that is nearer to 16, which is a base 2, is supposed to be 16. 16 minus 16 is equal to 0. Okay, I'll show you how to go about the whole thing. So the generated place value is 16, and the normal base is 16. Then we have 8. Then we have 4. We have 2. And lastly, we have 1. Okay, remember the rules? Okay, let me write this one down. And 2 0 is equal to 1. 2 is equal to 4. 3 is equal to 8. 4 is equal to 16. So these are the factors that you consider. Anything raised to power 0 is always 1. Then 2 by 2, 4. 2 by 3, 8. 2 by 4, 16, and going forward. So that's why if you look at what we have 16 is the highest value, followed by 8, followed by 4, followed by 2, followed by 1. Okay, let's move to the next part. Okay, remember we have said that if you get the generated value, which is the same as on the normal base 2 place value, you're supposed to write 1, this condition. I hope you have noted this one. Okay, let me do this. Okay, so we have a third one and a third one. Let me use the size. I hope you are seeing. Okay, look at the rule. We have already done that. The nearest number is 16. Then we have written the number that we have. So look at the last condition. So you write 1 below the place value that exists from this part, that exists from both the generated and the normal place value. This one. Okay, let me make it that one. So if this one and this one is the same, you write 1. But look at now the right part. You write 0 below the place value that only exists in the normal. 0. If you look at the other number, they only exist. As you can see, this is 0. So there is no other number on the normal. So you write 0 on the other number. So just like that. So the final answer will be 1 0 0 0 0. Then we have the base 2 as our answer. Let me get this to base 2. We have sub base 2 like that. So that is our answer. So what we have done, we have converted this one. This is a decimal to the other part. I hope you have understood what we have done on this part. Okay, let's move to our next example. I will be a little bit fast because we have already covered the the other one. So think of a number 64. The number that is near to 64 is 65 is 64. Sorry for that. And you will get 64 by this one. You get that other value. Okay, maybe I should demonstrate how I have been able to arrive to it. So 0, you get 1. 2, you get 4. 2, 3, you get 8. 2, 4, you get 16. 2, 5, you get 32. 2, 6, you get what? You get 64. So that's how I've been able now to arrive to 64 as the nearest number to the given one. Okay, so this is 64. So the number is 64. Therefore, the normal number have 64 followed by 32. The other number is 32, 16, 8, 4, 2, and lastly the 1. Okay, as you can see, there is no other number that is near to 32. So you jump that, you move to 16 the same, 8 the same, this one the same, this one the same. But if you look at this one is 1 as the reminder. So 1 minus 1, which will give you 0. So the final other number that we have, let me extend this one. So the other number that we have is this one. So meaning that we will have 1 there. So remember the rules. If the number appears on the generated value and the normal value is supposed to give you 1, the same as these other one. But if it appeared only on the normal base 2 place value, it's only supposed to be 0, 0, 0, 0, 0. So the final answer for my case will be 1, 0, 0, 0, 0. So we are supposed to have 5 zeros, 5, 1. Then the base is supposed to be base, then the base 2. So that is our answer for 65. Okay, then we move to our last example. I hope up to that point we are together. You are following what I'm doing on this one. So for that one, the number that is near to this one, I hope by now you have understood how I was coming with the number. The number that is near to this one is 16. The generated place value will be 16. Therefore, the number is 16. So 16 minus that one, you get 15. Now the number that is near to 15 is 8. So we have 15 minus 8, which will give you 7. The number that is near to 7 is supposed to be 4. Supposed to be 4. 4 minus that, you get 3. The number that is near to 3 is 2, which is going to give us 1. Then the number 1 minus 1 is equal to 0. Then the generated number, here we have 8, here we have 4, here we have 2, here we have 1. Then the normal is 8, 4, 2, 1. Remember the rules? Whenever it appears on the normal and the generated value is supposed to be 1, 1, 1, 1, 1. Therefore, the final answer will be 1, 1, 1, 1, 1. Then we have base 2. So that is the answer for on this one. That's the eventual answer that you'll get after you convert that one to base 2. I hope up to that point you have been able now to convert a number from decimal to binary using the place value method. So you can compare between the two cases, that is on the long method division and the place value method, and try to compare which one is easier for you, and will take the shortest time possible for you. But I hope by now you have understood on how to work on the two cases. Okay, so for the next one, in case you have any question or any suggestion based on what you have watched on my videos, just write it on the comment section or reach out on my email on my video description. Will be able to see my email. And also don't forget to subscribe. Continue supporting the channel by subscribing on it. I will truly appreciate that. Thank you, and have a lovely day.